a revolution of chemical engineering and applications in day-to-day life, and from there, we have talked about all the different subjects that should be involved, and finally we saw that the essence of mathematical equations. So we have the chemical process. And we have a chemical process, and this chemical process can be described in the mathematical format, which is algebraic system. Another one is differential system. So algebraic system examples: well-mixed system. I'll discuss individual different processes, and then we'll see much better when the algebraic system occurs. Steady state. There is no spatial gradient. Steady state with no spatial gradient. If there is spatial gradient, it could be there. If something is not changing with time, that is called steady state, right? If things are not changing with time, it's called steady state. But things can change in space. If that situation occurs, it won't give algebraic equation. So it's a well-mixed system. That means you are just putting star or kind of batch reactor kind of thing. Batch reactor is not a steady state. The things are changing with time. But where we have no spatial gradient, things are not changing with time, steady state, and you can get algebraic system. And typically, this is represented by Ax equals to B. Right? A is a matrix, X is a vector, B is a vector. Okay? And X is unknown. Right? X is unknown. Differential system. It has got two parts. Ordinary differential equation. And partial differential equation. So ordinary differential equation, you have 1D geometry. Steady state, no spatial gradient. Sorry, spatial gradient could be there. No spatial gradients will go to the algebraic system. So we can have steady state. There is no time dependency. 1D equation means it will be having only one derivative, right? Only x or y. 1D, no? One dimensional means either x or y or z. There is no time dependency. So the dependent variable is y. It could be dy dt or dy dx or dy dz, something like that. Or if y is the concentration. In that case, only one derivative is there. One independent variable is there. Since when one independent variable exists, in that case, you have the equation must be ordinary differential system, because we have got only one derivative, one independent variable. Next is partial differential equation. What we have? Okay, let me finish here. The question comes with a well-mixed system. We can have ODE. Of course, well-mixed system we can have if you have unsteady system. So if you have the star like CST, continuous star and reactant reactor, if you have the star, but things are changing with time. But because something is coming inside and things are some reaction going on, something is changing with time. But you have well mixed. That means within the space there is no gradient. Things are well mixed. But things are changing with time. Okay? That means you are having derivative like this dc by dt. dc dx, dc dy, they are not there. Only this derivative is there. Even for well mixed system. Because unsteady state system is unsteady state system. Well mixed unsteady state system. Okay? So in that case, there is a chance So here you saw that well-mixed system, steady state, always algebraic, but well-mixed system, if you have unsteady state, you get ordinary differential equation. Okay? But now partial differential equation. We have 1D, 2D and 3D. Unsteady state, we can switch on all the criteria. Unsteady state, and we have space gradient. This will give the PDE, partial differential equation. That means unsteady state means dou C by dou T. C is the concentration, for example. Space gradient is there. That means we can have dou C dou X, dou C dou Y, and so on. You can see that so many independent variables are coming. We know that partial differential equation exists if there are more than one independent variables. Right? If there are more than one independent variable, in that case, the derivative, the differential equation will be nothing but the partial differential equation. Right? Otherwise, if there is only one independent variable, the differential equation is ordinary differential equation. Right? Okay. So we can also have steady states, OD, PD, which is 2D, 3D system. We can have a steady state, space gradient. That means what? The 2D and 3D system, steady state, but you can have dou C dou X, dou C dou Y, dou C dou Z. Dou C dou T not there, doesn't matter. But you have dou C dou X, dou C dou Y, so there are more than one independent variables. Even for the steady state, 2D and 3D system, we can get the partial differential equation. And all those things actually occur in chemical engineering. We have well-mixed system in chemical engineering. We have steady state. We have well-mixed unsteady state. Also there you have a, imagine that we have pouring some of the material and things of some reaction going on. Product concentration is changing with time, and your things are coming continuously. Okay, unsteady reaction going on, or some heat transfer going on, and which is in a start time, heating is actually changing with time. That is also the that is giving the ODE, and PDE means you have a wooden block, or you have some kind of big block, and things are changing with time. Things are changing with temperature. This kind of physical situations also occur, and we get partial differential equations. So, as a chemical engineer, we need to learn algebraic system, need to learn ODE and PD. So, in this entire course, what actually we will do, we will talk about all this spectrum of algebraic differential and partial differential equations. And the example of, I have given the example of algebraic system, which is Ax equals to be very simple. The algebraic system is very simple. But if we talk about the differential system, the ODE example I can give d to u by dx square. I just put it here. Example for ODE, d to u dx square plus u du dx equals to is ODE, and you can say only one independent variable. For the PDE, the example you can draw dou u dou t. I am giving most general example, grad square u equals to a. And grad square, you know that grad square, if you talk in terms of three-dimensional case, grad is nothing but dou to x, grad square is dou square dou x square, dou square dou y square, and dou square dou z square. So you can see that time x, y, z all constitutes, and these are the kind of equations which are called as partial differential equation. These are called as partial differential equation, and this is the ordinary differential equation. So this is the format of the mathematical methods in chemical engineering. So we will first talk about algebraic system. We discuss, we analyze algebraic system, how it works and what are the properties, how we can analyze the solution, and how any of the process which occurs in chemical engineering, how we can actually address that problem. We will start from process calculations. We will see the process calculation. There is so much mathematical beauty in process calculations. You must have got bored even when I studied process calculation long back. I thought there is not much mathematics, only stoichiometry, but there is a beauty in process calculations I will address in this class, and I will show that the concept of tensor, you might have heard vector, right? The concept of tensor would be applicable in process calculation, and process calculation nothing but a world of beautiful mathematics that I am going to address in a couple of lectures. Okay, so this algebraic system, differential system, ODEs and PDEs, they can write in commonly one of the format in single equation, which is very common, which I write as LU equals to L. L is an operator. So L is called as operator. U is called field, vector or variable. And F is some function which could be known function, which has to be known function. So this operator could be the matrix operator, could be differential operator, could be integral operator. Integral operator is out of syllabus of chemical engineering. I will not teach. I teach only differential operator and the matrix operator. Okay, so matrix could be matrix operator, could be differential operator. So the entire spectrum of algebraic system, differential system, partial differential equations can be written as LU equals to F. So for the algebraic system, what is L? Matrix A. What is U? X vector. Okay, and F is V vector. And for the differential system, for example, this case, what is L? Okay, any hands please? If you don't raise hands, because so many people are talking, I won't be able to know which is giving the correct answer. Your answer could be wrong, fine. Yes. Plus. Okay. Yes. D square by dx square plus dy dx. Where is the u? Okay. Just a minute. I will get justified. You are saying your operator is L equals to d2 by dx square plus d dx, right? That's what you said. Am I correct? So now, if you put all the variables, you should get back the same equation, right? Like you got Ax equals to b. Let's see. So LU equals to d2u by dx square plus du dx, but u is missing here. So this is wrong. So it could be u dx. So in that case, if you put u, so when you put u, that u is actually operated by d2 dx square. Okay, so if I put u, we just see where is the operator. So there are different operators. So operators called ddx is operator, d2 dx square is operator, d3 dx cube operator. So this is nothing but combination of operators. Okay, could be u, could be y, could be anything. But when I write LU, that means this u has to be operated by something, like a driver. This is a driver, this is also a driver. So it will be driven by this driver. Mathematics have to feel for that. I don't teach mathematics like mathematician. We have to learn mathematics like engineering. So here I will be doing mathematics like engineering, not like mathematicians. For not clear, operator concept. Similarly, when I say operator L here, what could be the operator here? What is the operator here? Now we have learned how the operator concepts are. Any answers from your side? Yes, any hands please. Without that I cannot accept the answer. Any hands? Yes, sir.
W by t minus.
Not dou down. It's dou by dou t.
Dou by dou t minus dou 2e or dou 2 by dou x square.
Okay, minus gat square. Why minus gat square? Why dou 2 by dou x square? So you can, so this entire thing you can write as dou u by dou t minus gat square u equals to f, and if you write Lu equals to f, so L must be dou t minus gat square. Right? So this is the way. So you can see that entire spectrum of algebraic ordinary differential equations, partial differential equations, you can write in terms of this format L is equals to F and L is operator. Any questions? Any doubts? Confusions? Clarifications? Nothing. Okay. So next we'll be talking about the application of algebraic system. I'll just give some of the, before getting into more on algebraic system, I'll have a glimpse of chemical engineering applications where we can see the algebraic system, differential systems, which would be ODEs or PDEs. Before that, before the applications, I will like to address something called homogeneous equation and non-homogeneous equation. When I can say an equation from here, homogeneous and non-homogeneous. When could I say that we are seeing homogeneous and non-homogeneous? A zero? Always. Homogeneous, non-homogeneous? Why? Because not zero. No, somebody said 0 is equal to minus 0. I am asking questions to you. I will give answer later on. You said something. So there are two systems. du dt whole square equals to 0. Another system is minus 0. Which is homogeneous, which is non-homogeneous? Both are homogeneous. What's the definition of homogeneous system then? Yeah, please. One of you. Order should be. So what is the order? Here order is. Order is different. Is it homogeneous, non-homogeneous? You are saying order. I don't understand what is order. Something she is talking about. So basically, the homogeneous system could be defined as in a differential in an operator if the dependent variable appears as derivative as function. No independent variable will be appearing as derivative because it's an all dependent variable. So in that case, the system, operator system, is called as homogeneous operator system. Okay? So let me repeat once again. In a system of operator, if the dependent variable appears either as function or derivative, is said to be homogeneous operator, homogeneous system. A non-homogeneous equation is one which has a term independent of dependent variable, which has some independent variable term. So I will give you the terms which is, for example, max square u, dou u dou x plus sin x equals to 0. If you look at dependent variable, independent variable, a non-homogeneous set of equations. So now there are many kind of things actually would appear. I will come back later on this aspect. And we can have classification as linear, homogeneous, linear, non-homogeneous. We can have non-linear homogeneous. We can have non-linear non-homogeneous. So that if I give a differential equation, you should be able to see the differential equation. So we have to characterize a differential system with operator. See, the point is when you have a matrix operator is very simple. Matrix operator is very simple. You cannot different unless the nonlinear set of algebraic equations. Generally, matrix operator Ax equals to B. We cannot do much here. Algebraic system. There is no question. So only one unique way you can actually solve it. But when you have differential system, lot of things actually come because lot of differential operators actually available. For algebraic system, you have only operator is A, is a constant matrix. For L operator, differential system could be ddx, could be d2 dx square, could be some u ddx, could be function of x, could be rho t, grad square, any 1,000 combinations actually appear. And with that, things are becoming cumbersome. And these are the ways we can actually differentiate the various systems. For example, if I give you a system du dt plus e to the power equal to 0, what is the system? Non-homogeneous? Only one hand please. Non-linear? Why it is non-linear homogeneous? How do you say it is non-linear operator?
Homogeneous because there is only one dependent variable.
Yes, correct.
Non-linear because there is an exponential term.
So there is some way to actually differentiate whether the operator is linear or non-linear. I'll get back to it. But remember that there are 4 things we have to remember: linear homogeneous, linear non-homogeneous, non-linear homogeneous, and non-linear non-homogeneous. So if you want to look at the various differential systems, how they actually appear, one of the things actually I would like to talk about in chemical engineering, which is pore diffusion. Have you heard pore diffusion? That Levenspil's book, right? Chapter 7, 8. I don't remember. Okay. Pore diffusion. Z equal to 0. Z equals 12. This is the R. Okay. So for this type of reaction, we have dou Ca by dou T, dAb, dou 2Ca, dou Z square, minus KAC. Reaction I am saying A going to B. What actually happens? This is the pore. Gas stream is there. It will come here. Reaction occurs here. And what actually happens? Product actually gets diffused out. So here diffusion process going on. I am not talking about chemistry. I am just talking about how the material is coming. Diffusion process going on, and the reaction is occurring here. Okay. This is the mass balance equation. Okay? We have done mass transport phenomenon in chemical engineering. So in transport we have seen a mass balance equation, and this is the diffusive transport, and this is the reactant is getting away by this reaction, first order reaction I am assuming, which is K minus KAC minus dCdt equal to KAC. So this is getting away. So pore diffusion is giving a beautiful partial differential equation. Pore diffusion is giving a nice partial differential equation, and you can see the operator here. What is the operator here? If I say Lu equals to F, it could be U equals to Ca. And what is my L here? Any hands please and give the answer? Any hands? Yes sir.
Dou by dou T.
Dou by dou T minus dAb,
dou 2 by dou Z square.
dou 2 by dou Z square Is that correct? Minus will be coming here and K should be coming here, plus K. Okay? I will give you the example. If you are really confused here, d2y dx square plus 5 dy dx plus 6y equals to 0. What's the operator here? One hand please. What's the operator here? d2y dx square
plus 5 divided
5 dx plus 6. Any confusion, anytime it appears, go to the simple algebra, simple differential equation which is there in your book, 10 plus 2. Whenever you have any problem, go back to your plus 2 level mathematics. This mathematics is so easy course. If you know plus 2 mathematics, you will be able to handle any part of this course. I will teach a lot of stuff, but you should be able to get back from the plus 2 level. Okay. So now we have seen how the operator is actually coming. So the operator actually you can see this operator format. Any chemical engineering problem you can write down. That's one beautiful thing. But this has time derivative, first order, second derivative in the space. So we need to have one condition for the time and two conditions for the space. So this time condition is called as initial condition and these conditions are called as boundary conditions. Okay? So at z equal to 0, one can have Ca z equal to 0 is Ca 0, and at z equals to L, this point, you can have minus dAb dCa dz equals to KAC. Okay? So we can see that whatever actually is coming by diffusion, it is getting into the reaction. This kind of boundary, any kind of boundary you can set it, no problem. We can have impermeable wall, also many things we can actually have. But we have essentially two boundary conditions. Remember that whatever the order of derivative in a particular independent variable, the same number of boundary conditions is required. First order derivative for time, only one condition is required. Second order derivative in space, two conditions are required. And of course, at t equal to 0, we have to specify at t equals to 0, Ca equals to 0 for all z. Okay? So if you define all the boundary conditions, then only you can solve this problem. So, thing is that now you can see differential operator is so complicated. When we talk about algebraic system, Ax equals to B, A is the matrix operator, we don't need any boundary condition. Directly you can solve, right? Ax equals to B is what? If you want to solve x plus y equals to 2 and 2x plus 3y equals to 5, we can directly solve it. The school level mathematics, no boundary conditions required. It is also n equals to L. This is also n equals to L. But it requires boundary conditions. So it has differential operator in build, and these are also operators, they are called as boundary operators. I'll discuss all those things details. I'm just giving a glimpse of the ideas, how things actually work in this case. So we have the differential operator and we have the boundary operators. So you need to have two kinds of operator. Here we have only one operator, which is a matrix operator. Here we have two operators. So when things are changing with time, things are changing with the space, unsteady state, same operator concept will apply, but don't think about only the governing equation operator. We need to have the boundary operators, otherwise you won't get unique solution. You can get a solution without boundary condition. That will not be unique. We define boundary conditions, we apply different solution you will get. That's what we don't want. As a chemical engineer, your client will get the solution, want to have solution. We cannot give a set of solution, you can say, okay, you can get anything. They will not complain. Your room temperature is fixed, your catalyst supply is fixed, everything is fixed. Based on that. So boundary condition is in our control. Human beings create boundary condition. I create impermeable wall. Okay, that means what? Dou Ca by dou Z equal to 0. From here, impermeable. So I create my own boundary condition. I see Ca equal to 0 initially. That means I am not giving any reactant. That is my hand. So boundary conditions are human made. So this part is controlled by human beings. This part is controlled by physics. So chemical engineering is nothing but the communication between physics and human beings. When physics and human beings both are working together, you solve the chemical engineering problem. Or not here? So this part will be discussed This part will be discussed from physics. When you combine, you see the beauty in chemical engineering. Right? So this is one of the, I have just given one of the ideas. I'll be going next on another couple of problems, and we'll see how things evolve. So this is one of the upward reactions we talked about. Next we'll talk about heat transfer. So this is the application for the chemical reaction engineering. Next we'll talk about heat transfer. Let's see how the mathematics is. So I'm just picking up the subjects and seeing the mathematics. How it is coming. You have seen the chemical reaction engineering. Chemical reaction engineering looks like very boring. It's of course not. It has got tremendous amount of mathematical challenge. I'll share some of the part, not the entire part. Okay? Then in chemical engineering, chemical reaction engineering is a subject. If you want to do mathematics, you can do such level of mathematics where mechanical engineers cannot even imagine, electrical engineers cannot even imagine. Only chemical engineers can do. I'll give one example. People talk about n-dimensional vector space. People say there's a crap. N-dimensional vector is, how can we imagine? We know 1D, we know 2D, we know 3D. Astrophysicists talk about 4D. X, Y, Z and T. Where is ND? In dimension. Of course, chemical reaction engineering will give you answer. Why? Because you have n independent species. Each species will be acting as a component, and that will give n-dimensional vector space. And that's what the beauty is in chemical reaction engineering. So, if you want to do tremendous mathematics, if you want to talk about the mathematical stuff, chemical reaction engineering is the part where you can see the spectrum of vector tensors and the differential equations. Let's talk about the heat transfer part and talk about the field problem. You know the field, you have seen the field, right? In your BTech level. Field could be three-dimensional. Okay? Things are changing with time, things are changing with space. Of course, what you expect? Partial differential equation based on our formula. You will expect partial differential equation, right? So what do you get? What's the balance equation you write? Accumulation term, like first class I talked about. Balance equation. Like here, accumulation term, which is consisting rate in minus rate out. It is consisting of rate of destruction there. Okay? Similarly, what's the accumulation term here for the heat transfer? When you construct the equation, the basic law I have given to you in the first class, accumulation equals to in minus out plus generation or destruction. What is that? Any ideas? Accumulation term for the heat transfer. You have done heat transfer, right? In BTech level? Yes. Any hands please? Accumulation term. Accumulation term. I'm just hearing some buzzing, but I'm not hearing any kind of convincing answer for the accumulation term. Any accumulation term you are thinking in your mind? Yes? That is, I want the mathematical part. Mathematics. V goes, but accumulation is the time dependency, right? We have seen accumulation, rate of accumulation. I should say rate of accumulation. Rho Cp, rho T by rho T. Why rho is coming? There are a lot of independent variables, three-dimensional field. The variations will be there X, Y, and Z and T, right? So accumulation term is rho Cp, rho T by rho T. What's the balance equation then? So rate in minus rate out. How do you write? You have done the shell balance equation, right? Shell heat balance or shell energy balance equation. What it gives in this term? The shell energy balance. If you look at, you can get the answer. Answer is given here. What is that? Who is giving answer? What is that? Only X, no Y, no Z. Three-dimensional. Okay. K. Dou 2T, dou X square plus dou 2T, dou Y square plus dou 2T, dou Z square. That's it. So these are partial differential equation. So, and here we need to have boundary condition, X direction 2 boundary conditions, Y direction 2 boundary conditions, Z direction 2 boundary condition, and time 1 condition. If you have all, then only you can get unique solution, otherwise you cannot give solution to your client. Okay? So operator is quite straightforward. Here the operator is, we will give the operator. Here the operator is, yes, operator, LU equals to L. What was the operator here? Do you understand this problem? Okay, yes please, last bench. Okay, only one person, please. Rho Cp, dou T minus K in bracket dou x square, dou y square, dou z square. Right? Yes? Okay. So we have seen the different kind of operators or different kind of problems. There are operators in the quantum mechanics. I don't want to talk about that because we'll be concentrating on the on-chemical intelligence. Of course, 2x plus 3y equals to 5, x plus y equals to 2. What is the operator? I have gone to the school level mathematics. 1, 1, 2, 3. That's it. That's the operator. X square plus y square equals to 2. 2x square plus 3y square equals to 5. What's the operator? No, it cannot be. See, if you say same, okay, somebody said same, I have to say why it is not same. See, if you now go back, how to go back? You can write 1, 1, 2, 3, x, y equals to 2, 5. So it is L, U equals to L. X is a vector, 2, 5, U is a vector, which is x. Now somebody is saying same. That means what? 1, 1, 2, 3. What should I write here? X y or x square y square? If you say x square y square, what will happen? X square plus y square, it will be 2x square plus 3y square. Okay, my problem is, I'll put like that something. I didn't imagine that you'll be thinking like so trivial. What will happen? What is, now you got my point? Okay. What is operator? Now completely bold, right? What is that? 101. How many matrix size? How much is matrix size? 2 by 2. We are saying 10 or something. You are saying 2 by 3 matrix cannot be. So square matrix. How can we 2 by 3 and all I come? Why matrix cannot be square here? These are all issues will be addressed in this class. The matrix is non-square. It's a dangerous system. I will be coming back when I talk about algebraic system. But now let us assume it's square matrix, simple system. So thing is that you cannot write in this format. This you can write as operator f vector u vector equal to 0. This is the function. This is called sort of vector of the functions. This I can write as f1 xy equals to 0. This I can write f2 xy equals to 0. Am I correct? And these two functions will be giving the function vector. So this is a function vector operator. Okay? The function vector operator. Where f bar is nothing but x square y. So you cannot write f bar. You have to write f bar u bar, which is nothing but x square y square minus 2. And second row will be 2x square plus 3xy minus 5. So f bar u, which is nothing but x square plus y square minus 2 and 2x square plus 3xy minus 5 equals to 0. So in this case, you cannot write f bar separately. You have to write f bar here. Similar kind of thing happens in the integral operator. I am not going to address because we don't come across the integral operator. Unless you want how integral operator looks like, I don't think you want so much of complication. If you want, please raise the hand. I will discuss the integral operator. So no hands. So I will go to the Next topic. Okay. So much we have learned about the operator. I think we have learned enough of the operator. Only part is left, which is linear operator, which is non-linear operator. We have left from there and could not complete it. Now let's talk about, so since we have learned so much of the operator, we will now discuss what are the characteristics of the linear and non-linear operators. Remember today's classes is 2 classes, right? So first part will be over 50 minutes.
50 minutes, yeah.
Per second. So linear and non-linear operators. So the property is for linear operator, L alpha u plus beta v, which is alpha Lu plus beta Lv. Alpha and beta are the scalar quantities. Alpha and beta are the scalar quantities. Pick up the examples to test whether operators are linear or non-linear operator. First example problem. x1 plus x2 equals to a x1 square. I have done slightly naughty thing here. If I would have put x1 plus x2, it would have been fine. But that cannot be, because same equation cannot have the both two right hand sides, different right hand sides. So has to have the solution, and x1 square plus x2 equals to a, x1 plus x2 equals to b. Now you are applying this formula, applying this principle of the operator theory. Can you say this operator is non-linear? First problem. How to attack this problem? How to attack this problem? How to attack this problem? How to write the operator set? How to write the operator set? If I say here LU equals to it is nothing but or you can say some C vector because B is already there. Okay. So what is my F bar u, which is x1 square plus x2, x1 plus x2. Am I correct? Now can you please apply? I am saying alpha equals to 1, beta equals to 1. Any scalar quantity, no? Alpha and beta is scalar. I am saying alpha equals to 1, beta equals to 1. You can put it in generalized way. I am just saying alpha equals to 1. And beta equals to 1. What do you get then? So you have to prove that f bar of u plus b bar should be equals to f bar u plus f bar b. If it is not, the operator is non-linear. Am I correct? Okay, what you are getting there? What are you getting? Remember that f bar u is this, f bar b is, you can say directly you can write u square x1 square, correct? You can write u1 and v1, it's better. u1 square, u2, v1 plus u2. Here you can write v1 square plus v2, v1 plus v2. Okay? Any questions here? I am not getting any buzzing here. Everything clear so far? I am defining the operator based on that. F bar U bar is U1 square plus U2 and U1 plus U2. F bar V bar is V1 square plus V2, V1 bar V2. Remember that if you want to see what is this, it is nothing but F bar X bar, which is X1 square plus X2, X1 plus X2. I am just replacing X by U and V. Okay? Or you can prove F bar X bar plus Y bar is nothing but F bar X bar plus F bar Y bar. Keep the operators linear. But here we will be going to show that is not. How to prove it? What is F bar U bar U plus bar V bar? So you can write U1 square plus U2, U1 plus U2 plus V1 square plus V2, V2, V1 plus V2 plus what term? 2. Am I correct? Yes. This is nothing but F U bar. F bar U bar, right? This is nothing but F bar V bar. This is extra term. So they are not same. If you add this, operator is non-linear. Any questions? Any doubts? You didn't understand this part? Okay. How you got it? You just substitute. See, x bar is a function. If you replace x by u plus b, it is u1 v1. So u vector is what? u1 u2. V vector is v1 v2. X vector is x1 x2. I thought it is so trivial, that's why I didn't write it. X vector is x1 x2. U vector is u1 u2. V vector is v1 v2. So if you replace fx bar by u plus v, then the first vector will be u1 plus v1. Second will be u2 plus v2. So u1 square plus v1, u1 square plus v1 square, 2 u1 v1, u1 square, v1 square, 2 u1 v1. u2 plus v2, u2 plus v2, nothing is there. Similarly here, u1 plus v1, u2 plus v2. This is fu bar, this is fb bar, this is the extra operator. They are not the same. So this is a nonlinear operator. Questions, doubt, confusions? Okay. Some of the things I feel sometimes trivial, I won't be able to explain you. Please catch me, then I'll be explaining further. Clear? Okay. So we have proved that here this is not valid, so it is nonlinear operator. Next question. I've been only talking about the complicated problems here. And some of the things I have given the problem set 1, you can get back to the problem set and see some of the problems. Next question. Differential system. d2u by dx square plus u du dx plus u equals to f. Of course, it's nothing but LU equals to f. So if it is given here, you have to write LV equals to f. And then you have to prove LU plus V, question mark I am putting here, LU plus LV. You can put alpha U and beta V. That's for the exam, not here. I am just putting alpha equals to 1, beta equals to 1. Alpha and beta could be any number. Could be 0.3, could be 0.4, could be anything. Can you justify whether it is equal or not? I am putting a question mark here. Can you justify? Can you justify LU plus V equals to whether it is LU plus LV or not? So what is the left hand side? Which is LU plus V. What should I write? What is my L? L is d2 dx square plus u dx plus 1. Plus 1. Now, point is, what will happen when you put LU plus V? Let's see that. How do I address this part? When you do the operator, when you put U plus V, what will actually happen? Okay, so this is the question mark. You do it. I want to see next time because I have shown on the previous one here because I have to move to the next one. I cannot. I will see in the next class what you actually can get it. Did you get it? Yes or no? How did you get it? Anything quick?
B square by dx square plus 2.
Yeah.